Prove that the medians of a triangle are congruent, the point of congruency dividing each median in the ratio 2:1. Also write the position vector for the centroid of a triangle. Now, given a triangle ABC where D, E and F are the midpoints. In triangle ABC, D, E and F are the midpoints of BC, CA and AB respectively. Let vector A, vector B and vector C be the position vectors of A, B and C relative to some origin of reference. Now, position vector of D, E and F, position vectors of D, E and F are, now for D, now we are having vector B plus vector C, for E and for F respectively. Let G be a point where medians AD, BE and CF intersects. Now, the position vector of point G dividing AD in the ratio two is to 1 is, now this is equal to 2 with B plus C upon 2 plus 1 with A vectors. Upon 2 plus 1. Now, what we have used here, section formula upon m plus n and m ratio n is equal to 2 ratio 1. So, we have used this one, and what the result we are getting? We are getting 1 upon 3 A plus B plus C. Now, similarly, position vector of BE and position vector of CF in the ratio similarly position vector of BE and position vector of CF in the ratio 2:1 at point G are equal to vector A followed by vector B followed by vector C. Okay. Thus, the point G dividing AD in the ratio 2:1 also divides BE and CF at the same ratio. Okay. Now, we have proved that point G divides AD, BE and CF in the same ratio, and that is 2:1, and the point of G is 1 upon 3 in the bracket A followed by B followed by C. Hence, median of a triangle are congruent and because this is the second part. Also write position vector of the centroid. Now, and the position vector of centroid, that is point G. G is the centroid. The position vector of point G is 1 upon 3 vector A followed by vector B. So, this is the result.